All right, so we're given these four position vectors, and the first thing we have to find is the position vector of M, and what is M is the midpoint of AC. So we really need to find AC first. So let's go ahead and find AC. So we'll take A, B, C, D. We'll take C and subtract A, and I'll write it over here. You see we'll get 4 minus 1 minus 1. All right, so that's AC. So therefore, if we're looking for M, or the position of M, so we're looking for OM, and it's halfway along AC, then we would, if it helps, draw a picture. Something like A, B, C, it could be anywhere, I'm just drawing it like this. And AC, the middle of it is M. So another way to find, OM, let's say O is here, is to go OA and then AM. So sometimes you might need a picture just to see it, or you could use your algebraic knowledge. So to go from O to M, I just have to slip a different letter in between, and that happens to be, in this case, A is quite handy. So let's see, OA, so that's 0, 1, 2, and A to M, so I'm going to take M and minus A. So I've found I'm finding M. What am I doing? I need to find AM, which is halfway across. I rubbed my picture off, halfway across AC. So I'm going to go half, just instead of this, I'm going to put half AC in there, and AC we've already got. Okay, there we go, half of that. So putting that together, we've got half of 4 there, 0 plus half of 4, negative a half, 1 minus a half, and 2 minus a half again, so 1.5. So our M position vector is 2.5 and 3 on 2. All right, so hopefully you've written that down, because I need some room. Actually, I'll keep writing, I'll rub that out soon. All right, so find the vector equation for the line BD. So if we want a line BD, we want the direction of BD and then a point on BD. So you can use either point B or point D. So let's use the point B and get the direction from BD. So we need BD first. So we've got the direction of this vector. So we're going to take D minus B, and we should get 4, 2, that's a 0, isn't it? 2. So once we've got the direction, then we've got the line. So this line BD goes through a point. You could put, it doesn't matter which point, the B or the D here. We know they both lie on the line. And then some scalar of the direction. And the direction is 4, 2, 2. Just like so. So then if it says show the M lies, this is C, lies on the line BD, then we've just got to find what the scalar would be in order to give us that M. So remember, here's M. Let's go 2 is kind of the easiest. So if I just look at the first thing, I've got a -1 and then a 4 lambda. So that has to equal a -1 and a 4 lambda. So what would lambda be for that to be 2? Well, we can see actually that's 3/4. So I'd add 1 to both sides is 3 and then divide by the 4. So I've got lambda is 3/4. So if we let lambda be 3/4 in here, we get -1, -1, 0 plus 4 lots of 3/4, 2 lots of 3/4, which is 3 on 2, and again 3 on 2 here, which gives us -1 plus 3, 2, -1 plus 1.5, and 0 plus 3 on 2. So when we let lambda equal 3/4, then our line gives us the point that we were looking for, the point M. So we could say, sorry, I've run out of room, but we could say, let lambda equal 3/4, and then we get the point M. Therefore, M must lie on that line, BD. All right, now it talks about BD again, which is a problem. No, BMMD. All right, BMMD is what we have to find next. So hopefully I don't need so much of that, but hopefully you've written that down. So if I want BMMD, I definitely want the vector BM and the vector MD. So let's do that first. Hopefully you've done it and you had no problems with it. Okay, so vector BM, let's have a look at that. So I'll take M, which was, goodness, I think that was correct. Take away B, so our B is still there, so we're all good. I'll just put it over here. So when we do that, sorry about this working, we get 3, 3 on 2, 3 on 2. And when I do MD, I'm going to take D, and subtract M. And do that, I get 1, a half, a half. All right, so you can clearly see BM is bigger. So BM, let's just check. To get 1 to 3, I need 3 lots of MD. Let's just check that that works. So 3 lots of a half is 3 on 2, 3 lots of half is 3 on 2. So that works nicely. So if that's the case, then BM, the ratio of BM to MD, that interval, must be 3 to 1. There we go.